Awesome. Thanks everyone for coming out. I realized the title was kind of a mouthful, so I figured we'd just change it to Mapping with Photos. And that's really one of the big ideas with this is how can we get more people participating with mapping and doing crowdsourcing and collaborating around maps in interesting ways. And one of the challenges with traditionally the way we've done mapping with photos, and there's a great, wonderful lineage of this, like going back to Flickr, which is like the Flickr photos of all the geotagged photos in New York by location, and it's really wonderful. So, but one of the challenges with that is that the location of the photo is where the person who took the photo, or more appropriately the camera, is located, and not what the picture is being taken of. And so many times when we want to map stuff, right, we're not necessarily mapping the locations of people, we're mapping things like buildings and streets and points of interest and fascinating places and landmarks. But as you can kind of see in the photo here, it's like, pictures of a track meet, and you look at the locations on the map there, and it's like somebody sitting in the stands, somebody kind of off the stands, and it's not actually the location of the thing that's being photographed. And so we thought this was kind of like a cool opportunity. Could we have some fun with math and see if we can figure out not only the location of where the person is taking the photo, can we also take the pose of what the camera's pointed out, what its angle is, what its intrinsics and orientation are, and then figure out what that field of view looks like, and then intersect all the great data that's in OpenStreetMap and any geographic feature database, and figure out what the photograph is of. And then if we know what the photograph is of, we can do some cool, interesting things with that additional data. So that was kind of the little experiment that we were doing. And the kind of question, if you're into this kind of stuff with computer visions and cameras and reconstructing stuff, is normally people say use visual positioning systems for this. So if you've ever used like Google Live View, for instance, you hold it up and Google scans your location, it matches it to a pixel database from Street View, and then it figures out your location and does some cool AR overlays. And so from that standpoint, it is definitely figuring out where the pixels are. But in OpenStreetMap world and most of the other kind of vector mapping world, right, we're not working in pixels, and that we don't often associate pixels with a building footprint and a POI and a street address and a street. We keep that in raster space. So there's kind of some downsides. It is wonderful for localizing you, and there's lots of great aspects to it. But when you want to work with vector data set, it creates a little bit of complication. And so we wanted, basically, could we come up with a poor man's localization? Could we come up with a really simple way, just using sensors and vector data, to localize the device and figure out what you're taking a photo of? And so the way we do that is we try to get a much more precise location for the GPS on the phone, which I'm sure, as all of you know, going around Boston, your little blue dot can wander a bit and be on the wrong side of the street or across the river, and slowly it gets a little better over time. But especially as you get around big buildings, right, it tends to wander and kind of get a mind of its own. And so we've been working on kind of come up with clever ways to make that blue dot more accurate and get it in the right spot. And one of the cool side benefits of that is you get that blue dot in the right spot, and you start working these kind of like PBT filters to fuse these things and bring in other sensors like your IMU. You can also figure out the orientation. And so basically what we do is we take that location of your blue dot and then take the orientation of what way you're pointing, and then we calculate a field of view. And so like, I'm looking out right now and I can see this if I'm facing here. And if I move, my field of view goes over there. And we're basically just calculate that in real time of what that field of view is. And then we have OpenStreetMap data, right? And so we can say, oh, what thing in OpenStreetMap is your field of view intersecting as I'm looking around? And then we can tag that thing. And so the cool is then when you decide to take a photo, we can just take that tag in real time and say, oh, you were looking at the BU Sherman Student Center or Union, and I know that's the thing that you were looking at. And that gives us some opportunity to do some cool stuff. So in kind of the computer vision world, they call this 6 degrees of freedom. So you have your latitude, longitude, altitude, which we in this room work with a lot. And then computer vision people also think about yaw, pitch, and roll of like, is again, that kind of orientation in 6 degrees of motion. And then we want to take a database of geographic features like OpenStreetMap, and then we also want to look at imagery. Not only like imagery that we're taking with the photos, but also other imagery that's already out there. So we have other wonderful projects like Mapillary and Cartocam that are out there collecting imagery all the time with phones and dedicated cameras and other things that have this kind of position and pose data. And so we can begin to put those things together and do some fun experiments with it. And so that's basically what I wanted to share was running these experiments. And as we ran them, and we've been doing some version of this for a couple of years at different places, is that one of the things that kind of wreaks havoc is that GPS accuracy I was talking about. And this is a paper from Google a couple of years back kind of showing them trying to improve this process with in urban canyons. And you can see their improved one is in turquoise, but the baseline, which most everybody's phone runs against, is this red line. And it's kind of all over the place, right? But if I'm taking a photo of a place, I want to make sure that it's perfectly aligned. And so here you can kind of see, you know, an optometrist that's in our local town, and there's my little blue dot. And you can see the crack in the road in the satellite image, and then in the real image where I'm taking it, you can also see the crack of the road, right? And so you want to line these things up, because if they're off, then the thing you're intersecting, you're tagging with the photo could be wrong, and then all your mapping gets a little wonky and not great. And so that's a lot of what we think about, like how do we get really good sensor measurements to register locations and then get really good data that we collect, then map up with the location of the user. And so we did a couple of experiments. One was we would take that position and we collect a lot of mapillary data for that place. So there might be like a POI, like this is the Huckleberry restaurant, which is a great little breakfast place in our little downtown. And so you know, we basically say if we, let's take all the photos within 50 meters of that, and then take the camera poses and see which ones include where the Huckleberry is, and then we'll take those photos out. But I'm sure as a lot of you have worked with POI data at some point, sometimes that place is not in the right location. It's, you know, it was used a geocoder, and they put it on, you know, the wrong side of the street, or in the middle of the street, or set back from the street. These things tend to vary quite a bit. So in a lot of POI databases, you kind of get these variations in location. And so the experiment we wanted to do with this kind of like programmatic tagging thing was, if we had a big resource of a, you know, either people taking dedicated photos of the place and tagging them, or we had mapillary data that we could go and run and do that for an existing data set that's already out there. Because, you know, my crowdsourcing is app great if I go and do that in my local neighborhood, but if I want to try doing this anywhere in the globe, I can try these different data sets and kind of see what works. And then and so we decided to do a twofold experiment, especially kind of given the audience, that wanted to look at doing this experiment for relocalizing points of interest in Overture and points of interest in OpenStreetMap and see how they compared. And it was a really cool, interesting experiment because it kind of shows you know, how projects complement each other and where there's opportunities. And so the fascinating thing we found with the Overture data set is that since they aren't user-generated POIs, that there's not a person there placing the POI and tagging it like you do in OpenStreetMap, the locations can often be off because a geocoder was used or something along those lines. And so here what you can see is we've run this, this calculation using that kind of programmatic tagging of a place, and then we do some computer vision math and triangulation to figure out, based on all those photos, where is the point of interest at. And so here we can see, you know, there's some kind of obvious ones where, you know, it put the point of interest for this poor wine house like way over on Pine Street. The actual location is there on the corner, so we were able to move that one and make a pretty big improvement. And so these blue lines are, you know, the long ones that were improved, and sometimes it was just a small improvement, right? It's kind of on the street, and you set it back to line up with the entrance on there. And so that was kind of, you know, in general, you know, we moved them about, you know, 13.5 meters was the average improvement as you go through this routine. Then interestingly, when we went and did that with OpenStreetMap, it was only a 5-meter improvement, and it kind of goes to the point that mostly for OpenStreetMap, you're not programmatically determining the POI. It's a person going out there and labeling it and putting the place in the correct spot. And this is again where you see some of this complementarity. While the median, the median was 5 meters, the mean was like 1,700 meters, because you can see this really long blue line, because there was a place that moved from the town of Lafayette, you know, 10, 15 miles away, and they moved their store to Louisville, but you know, OpenStreetMap hadn't updated it, and so when you did the relocalization, all of a sudden you have this massive gap, right? And that's kind of the trade-off, right? Where something like Overture, where you have lots of people contributing data from these different organizations, they're constantly updating the metadata with, like, you know, opening hours and moved locations and closed stores and things like that. But that same kind of programmatic approach introduces errors in one part, and OSM corrects that. But oftentimes, since OSM is, has this wonderful dependency on volunteers, we're not all out there checking, did this store move to this place every week? The stores are constantly moving all over the world and changing their hours, and one place closes, another place opens. It's a really hard thing to monitor. So it was really fascinating kind of seeing this complementarity between the two, of one thing excelling at locational accuracy and the other thing excelling at metadata accuracy. And then, that was great if we're out there taking photos. And again, that scaled great for Louisville. I could run around and have a good afternoon taking pictures of places around town. But then we wanted to see, well, if we wanted to do this for a much larger area, how could we do it? And so it's like, oh, wonderful, Mapillary has all this great open data. Let's use Mapillary. But one of the challenges with using Mapillary is, since you don't have a person taking the dedicated photo to anchor that location, it's just serendipitous photos, right? Mapillary, like Google Street View or Cartocam's, driving around just continuously running a camera, and those are being chunked into photos. But that driver is not saying, oh, I want to go take a picture of the huckleberry. I'm going to drive by the huckleberry, and likely I'll get a couple of photos of it as I drive by. So as a result of that lack of intentionality, you need to be able to do some QA of, even though these things intersect, it might not actually be the place. And again, that kind of goes back to the accuracy of the data, similar with the position. If that GPS dot is off when the camera takes the photo, or the camera pose is off and the orientation's not right, you get these scenarios where, this is the Verde restaurant. If you kind of look here, it has this really distinctive sign. It makes it easy to kind of figure out where it is. But a lot of times, it would say that it was taking a photo if you looked at just the computational geometry of the math, but it's driven past it. So if you look at this like green one here, the street's closed for like a street fair, but there's no restaurant in sight, right? And that's because the restaurant is behind me to the right. But the metadata for the camera and the GPS was off enough that I now have something that doesn't look like Verde at all. And so if I use that photo, it's not going to be helpful for me because it's not actually a picture of the place. And so that's a lot of what we thought about, of like, how do we get these things to align better? Because you have errors both in the Street View cameras that collect the data, and then you also have errors in the location of the POI as well. And so you have errors on both sides. So a lot of what we were thinking about is like, how do you line those things up to get rid of those errors so then you can do fun stuff with the data? And so here again, we see that it works quite well. If you use Mapillary, you do some good QA. And here again, we're like improving it about 15 meters on average across those locations. But with that in place, you can start to do some cool stuff. And so these are some of the applications that we've been doing. This is some folks in disaster management that we've been collaborating with. And one of the big problems in disaster management is, after a hurricane or a flood, and that building gets damaged and it's gone, is having to go through and do that damage assessment and figure out who owns that building. Do they need assistance from FEMA? And did that building get damaged, and verifying that? How much damage was there so they get the right amount of money? And that becomes really challenging because they get a bunch of ground photos that are just GPS points scattered all over the place, but they can't figure out, is that a photo of this building or that building? Is it on the north side of the street or the south side of the street? And so what we've been looking at is programmatically tagging them. So, taking that OSM building ID when you take the photo, and then knowing that that photo is of that building ID. So there's some cool things there you can do with programmatically tagging things. So as you're taking the photo, immediately relate that photo to things in OSM is one kind of cool thing. The other one that we've been playing around with a little bit more on the buzzy side is, can you then use all of that data to get a large language model to understand spatial navigation and reasoning? Because if I know where I am and I know what I'm looking at and I know what things I'm intersecting, can the LLM then tell me? It's like, oh, if you walk down the street another 50 meters and you look left, there's the Sherman Student Union. It's a concrete building with a red awning, and there's some flags with the years of BU students sitting in the window, and that can describe that to me. Because we have all this wonderful Mapillary imagery that we've now related with the point of interest, so we know not only where the point of interest is when the user's looking at the point of interest, but we also have a whole bunch of photos of that point of interest. And large language models are really quite good at turning those pictures into words, and then if you can constrain it and keep it from hallucinating, it can then tell you cool stuff. So in this case, the person's looking, and I'm asking them where like a delivery location is, and they say, oh, for the Moxie Bread Company, go to the yellow door on your left, 15 meters ahead, drop off the package. So we did a bunch of experiments that it looks like, oh no, access. Here, let me try this. So there's meant to be, see if it'll play one of them. Oh, here we go. See, is there volume? Volume's off. So in this one, I've asked the LLM, this place, the Empire Lounge downtown, is it to my right or my left? This is one of these basic things trying to get an LLM to understand what's on your left, what's on your right, what's in front of you, what's behind you. Well, if anybody wants to see it, I'm happy to share videos later on. I appreciate it. Thank you.